Find your 3.2a adding and subtracting positive fractions notes in your Unit 3 note packet. Distance learners, you did not receive a Unit 3 note packet from school. However, it is linked in the Unit 3 folder on Schoology. All the notes are in there, so you could very easily open that up and write the notes on a sheet of paper, or if you have a printer, you could print those out. Brace yourself. Fractions are coming. We got this though. We are going to review our 6th grade skills, also some 5th grade skills, before we move on to 7th grade skills. So what do you know about adding and subtracting like fractions, where they have the same denominator? There's nothing you need to write down in your notes right now. Well, look at this. So my first fraction here, you can see I have 1, that's my numerator. And from our lesson the other day, we learned that how many equal pieces the whole is cut up into, that's our denominator. So my whole is cut up into 1, 2, 3, 4, 5 pieces, and I have 1. So 1/5 plus, here I have 1, 2, 3, 4, 5 pieces, and I have 2 of them. So the problem would look like this, 1/5 plus 2/5. Does that equal 3/10? No, it doesn't. Let's look at this. If I have 1/5 and I add 2/5, look at my picture here. Here was the 1/5, I added the 2/5, I have a total of 3/5. So when we are adding, subtracting fractions, fractions are really division problems. So we have to use order of operations. Division would technically come before adding or subtracting. But when we're adding fractions with like denominators, we can get around this and still follow the order of operation rules properly. We are just going to add the numerators. No division is going to take place because we have like numbers in our denominator. So write these 2 examples down in your notes. On the left-hand side, also write down adding and subtracting like fractions as your title. And write this friendly reminder, add or subtract the numerators. Denominators are going to stay the same. And that's because we want to make sure that we recognize that fractions are division problems and we can't break the order of operations. So if we get like denominators, then we won't break the order of operations. All right, I'm going to walk you through these 2 problems. Let's practice adding and subtracting like fractions. Like fractions are where we have the same denominator, and we want that because then we get to kind of work around order of operations without breaking the order of operations rules. That's why we can't add the denominators as well. So 3/20 plus 7/20 is the same as, well, what's 3 plus 7? 10. I would ask myself, how many 20ths do I have altogether? I have 10. Now with your final answer, look, can you simplify that? You bet you can. 10 is half of 20, so I know that the greatest common factor these 2 numbers share is 10. 10 divided by 10 is 1. 20 divided by 10 is 2, and that is in simplest form. So if I have 3/20 and I'm adding 7/20, I have a total of a half of the whole. Let's do the next one, number 2. We're going to subtract this time. So 5/9, we're going to take away 2/9. Okay, notice my denominators are the same, so I'm working with like fractions. That's awesome, because then I just have to worry about the numerators here, and that's not breaking any of order of operation rules because fractions are really division problems, right? And division would come before subtraction in order of operations. So we have 5/9, and we're taking away 2/9. How many 9ths do we have? Well, what's 5 take away 2? 3. Now look at your final answer. Can you simplify that final answer? Yeah, 3 and 9 share a factor. What is it? 3. So I can divide both by 3, and I'm going to get 1/3. That is my final answer. So 5/9 take away 2/9 is the same as 1/3. I'm going to go like that so that doesn't look like a whole number there. So when we're subtracting or adding like fractions, we're just focusing on the numerator. Now, what do we do if we have unlike denominators? Nothing you need to write in your notes here. Just look at my picture with examples. I have a 1/3 and I'm adding a 1/6. Does that give me 2/9? No. Remember, if we do that, if we add the numerators and the denominators, we're breaking order of operations. We're completely ignoring that a fraction is a division problem. I need to, my first task, if I'm working with unlike fractions where I have unlike denominators, I need to find a common denominator. I need to think, what is a common multiple my denominators share? So look at 3 and 6. What is a multiple? Remember, multiples are what we get when we multiply together. So for example, the first 5 multiples of 3 are 3 times 0 is 0, 3 times 1 is 1, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Right? So 0, 3, 6, 9, 12 are the first 5 multiples of 3. They're what you get when you multiply a number to 3. So do 3 and 6 share a common multiple? You bet they do. They share 6. And if you ever were like, I don't know, you could just multiply 3 times 6 together, and that would be a multiple that they share. So now, since I know that they share 6, I need to write an equivalent fraction to 1/3. I need to think, what times 3 gives me 6? 2. I need to also multiply my numerator by 2. And what that is doing, look down here at my picture. I have 1 out of 3 pieces. If I'm all of a sudden changing this to 2, 6, look what happens. Watch, ready? It means I'm taking the whole and I'm cutting it up into 6 equal pieces. Do you see how my third then just shows that I have 2 out of the 6? It's equivalent to a third. So now 2 6 plus 1 6, how many 6 do I have? I have 3 6. I added them together there. Looking at my answer right here, can I simplify 3 6? Yes, that is the same as I have half a pizza, okay? Or I have a half. So when we are working with fractions that do not have like denominators or they're unlike fractions, we just have to find a common denominator, a common multiple the denominators share. Let's practice that. Let's go to our notes. We're going to do 2 more examples there. So add another title on the left-hand side in your notes. We are now going to work on adding and subtracting unlike fractions. So put this on the left-hand side as well. Find a common denominator. That's a common multiple that my denominators share. Write down our 2 examples. I'm going to walk you through these 2 examples. Pause the video if you need to finish writing things down. 3/4 plus 5/8, I'm not working in the same fractional pieces here. So I need to make these become like fractions. Then I just have to focus on my numerator once I do that. What does a multiple 4 and 8 share? Well, think of your multiples. 4 times 2 is 8. They share 8. So I'm going to write an equivalent fraction to get 8 in the denominator of this fraction by multiplying the denominator and the numerator by 2. So 3 times 2 is 6. 4 times 2 is 8. These are equivalent fractions, and now I can add my 5/8. Look it, I made them become like fractions, and then we can just focus on our numerators. So my denominator stays the same. I'm still working in eighths. If I have 6/8 and I add 5/8, how many eighths do I have? Well, what's 6 plus 5? 11. 11/8. Now, if you were with us last year, we looked at this final answer and we said, gosh, that's an improper fraction. Let's change that back to a mixed number. Now we are just going to leave it as an improper fraction, but we're going to check to make sure that our numerator and denominator do not share a factor outside of 1. So 11 and 8, do they share a factor besides 1? No, they don't. So this is my final answer. Let's do another example. So example 4 for this lesson, we have 2/3, and we're going to take away 4/7. Now, do I have like fractions here? No, so I need to find a common denominator, and that's a common multiple my denominator shares. So what does a common multiple 3 and 7 share? You might go, Ms. Clifford, I don't know. A really easy way to find a common multiple for your denominators is just multiply those together. 3 times 7 is 21. So 21 is a common multiple. Therefore, it's our common denominator. Now we need to write equivalent fractions with 21 in the denominator. So what times 3 gives me 21? 7. So I have to take my numerator and multiply it by 7. I'm going to get 14/21 minus, what times 7 is 21? 3. So I have to multiply my numerator by 3. That's 12. So now I have 14/21, take away 12/21. I have like fractions. So I just need to focus on the numerators. My denominator stays just as it is now. What's 14 take away 12? 2. Now look at your final answer. Can you simplify this anymore? Do 2 and 21 share a factor besides 1 right now? No, they do not. So this is the difference of 2/3 and 4/7. We are on to the final part of our lesson today. So I want you to think back. What do you remember about adding and subtracting mixed numbers? Well, maybe you're like, I don't know, Mrs. Kluver. That's okay. When we're adding or subtracting mixed numbers, the most efficient, easiest way is just to convert them into improper fractions. That's what we're going to practice. Go ahead, we're going to add 2 more examples into our notes, the final 2 examples for today. Add another title on the left-hand side, adding and subtracting mixed numbers. And here's a helpful hint to you. Convert to improper fractions. Go ahead and write everything down that you see on the screen in front of you. Pause the video and then come back and join me. Our last part of today is adding and subtracting mixed numbers. And we want to do this in the most efficient way or easiest way possible. And that is we're going to change them into improper fractions first. Suck up that whole number into the fraction so you don't have to worry about extra addition in there. I'll explain that in a moment. So write down, this is example 5. We have 5 1/2, and we're adding 3 7/10. Now, a mixed number is the sum of a whole number and a proper fraction. This 5 1/2 is really 10 halves plus 1/2. That's what this really is. So that 5 is this part right here. We want to suck that 5 up into the fractional part. So we're going to change this into an improper fraction by doing the Texas. The abbreviations for Texas are TX. And remembering order of operations here, multiplication before addition. So 5 times 2 is 10, plus 1 is 11. So we have 11 halves plus, same thing over here, do the Texas. Using order of operations, 3 times 10 is 30, plus 7 is 37 over 10. Now, am I working with like fractions? No, so I want to make them become like. And you might say, well, Miss Kluver, couldn't I have made them become like up here? Absolutely. Or you can do it at this step once they're changed into improper fractions. It doesn't matter. What does a multiple 2 and 10 share? Not a factor they share. What's a multiple that they share? Remember, multiples are what we get when we multiply. Well, if you're not sure, you can always multiply these 2 together, and that is a common multiple, a common denominator that they share. Another one that they share is 10. So I'm going to rewrite down here. 37/10 just gets to stay as it is because it already has 10 in the denominator. What times 2 gives me 10? 2 times 5. So I'm going to take my numerator and multiply it by 5. That's going to give me 55/10. And I need to add 37/10. Now, am I working with like fractions? You bet I am. So I just have to worry about the numerators. 55/10 plus 37/10. How many tenths is that? Well, 55 plus 37. 50 plus 30 is 80. 5 plus 7 is 12. So what does that give me? That gives me 92/10. Now, if you look at this, this is an improper fraction, yes? And we're going to leave it in improper fraction form. But now look, do 92 and 10 share a factor outside of 1? They do. These are both even numbers. So if we think of our divisibility rules, 2 goes into them. I can divide 92 by 2, and I can divide 10 by 2. 92 divided by 2, I'm going to come right down here because I'm running out of room. 92 divided by 2, you could use your calculator if you needed to. Or you can do some mental math. I can break 92 up into 80 and 12. 80 divided by 2 is 40. 12 divided by 2 is 6. 40 plus 6 is 46. Over 10 divided by 2 is 5. So 46/5. Now, 46 and 5, do they share a common factor? No. In order for 5 to be a factor of a number, it has to end with a 0 or a 5, and this one does not. So 46/5. Miss Kluver ran out of room with this problem right here. I was writing so big. So when it comes to adding mixed numbers, we want to change them into improper fractions first. Let's do one more. And this time we're going to subtract mixed numbers. And we're still going to change it into an improper fraction first to suck that whole number up into the fraction so we don't have to worry about it. So here's our last example for today. 4 1/9. And I'm going to subtract 2 2/3. Here's another way that you can write adding, subtracting fraction problems. You can stack them on top of each other like this. So looking at this problem, and I'm going to find a common denominator right away this time just to show you that you can do it both ways. So I can see that I'm not working with like fractions. I can see that I have mixed numbers, so I'm going to want to change those into improper fractions before I subtract. I'm going to start by finding a common multiple 9 and 3 share. What is a multiple 9 and 3 share? 9. And remember, if you're like, gosh, I don't know, just multiply these numbers together. That would be 27. That's a multiple that they share. Since I know that they share 9, I'm going to leave 4 1/9 as it is. I need to find an equivalent fraction with 9 in the denominator for this one right here. What times 3 gives me 9? 3. So 2 times 3 is 6. Okay? I'm going to do a little line here so that you can see what I'm doing here. There we go. Now, I am working with like fractions. But you might go, oh, Miss Clifford, can't you just go 4, take away 2? Yes, but then look over here. 1 take away 6. We're going to have to borrow a whole from the 4. Okay, and if you know how to do that, awesome. But there's a much easier way to work with this. We just change them into improper fractions. So we do the Texas. 4 times 9 is 36, plus 1 is 37/9. Take away 2 times 9 is 18, plus 6 would be 24/9. Now I have like fractions. I've sucked that whole number up into the fraction part. I'm ready to go. 37 take away 24. What does that give you? 13/9. Now, this is my final answer, but before I say, yep, I'm done, I'm going to look. I'm not going to change it back into a mixed number. I could, but I don't need to right now. In math, it's much easier to work with improper fractions. If we were doing a real world story problem, then we would change it into a mixed number. Okay? Because you wouldn't say, hey, I used 13/9 cups of flour in my cake, right? That just wouldn't work. You would say, I used 1 4/9 cups of flour to bake my cake. So mixed numbers are really nice for real world application. Improper fractions are really nice for working with in math. 13 and 9, do they share a factor outside of 1? No. So here would be the simplest form, 13/9. My final answer for 4 1/9, take away 2 2/3. The big thing here, 7th graders, is that when we are adding or subtracting fractions, we need to have like denominators, which means we need to have a common multiple, the same number in the denominator. When we're adding or subtracting mixed numbers, we want to suck that whole number up into the fraction part. So first changing them to improper fractions by doing the Texas.